We begin our studies for Chapter 3 with introducing ratios and when we use ratios as rates. We will begin our studies with proportions, percents in this particular chapter. We will revisit some types of word problems, but we will continue our work with solving equations from last chapter as well as we begin Chapter 3. So to start, we discussed that a ratio is a comparison of two or more numbers. Most often we'll compare two numbers, and any ratio that has more than two numbers compared is called a continued ratio. When we express ratios, we can either do them as a fraction or we can use a colon, one dot on top of the other, if you've never seen a colon. The main thing to remember about ratios is that they have to be put in simplest form, number one. And number two, they have to have the same unit of measure. Here's some examples to try here. We have two examples. We're going to express them with using a fraction and with using a colon. Pause the video at this point to give yourself a chance to do the examples on your own. So for 12 to 4, we're going to reduce that, and we express it as a fraction as 3 over 1, and with a colon we do 3 colon 1. It is essential to put 3 over 1, even though we are well aware of the fact that that just equals 3. We are talking about ratios here, so it is important to have that 1 in the denominator if you're going to express your ratios using a fraction. With 8x to 4x, we reduce that. The x's go away, and we're left with 1 over 6 or 1 colon 6. Here's some more examples for you to convert. Pause the video at this point to give yourself a chance to do the examples on your own. So for 75 grams to 100 grams, we're going to reduce that to 3 colon 4. For 3 to 15, we have 1 colon 5. 8 ounces to 1 pound, we have to be careful because they are not the same units. We should remind ourselves that 1 pound is 16 ounces. So it's really 8 ounces to 16 ounces, which gives me a 1 to 2 ratio. When we use ratios as rates, and we typically do this every day, there are so many that we can do. And rates are a different type of ratio that we'll express. There are a couple of differences that we need to talk about. But in your own mind right now, especially in your notes, we want to try and name some of the rates that we use every day. Perhaps if you are riding in the car with your parents, or even if you're a driver, you are using miles per hour as a rate every time you step in a car. One of the biggest selling points, speaking of cars, one of the biggest selling points at this particular time with cars is the miles per gallon. That's another rate, miles per gallon, gas mileage. If you're a grocery shopper and you go to the store with your parents, you've probably noticed the price tags, the little white price tags underneath all of the products. Well, there's also an orange spot that gives a unit price. A unit price is another example of a rate and how we can compare one product to another. To find rates, it's very simple. We first take the first number and divide it by the second number. You are allowed, unlike in ratios, you are allowed to leave things in decimal form here. One of the more important things, though, is that you do have to remember to include your units. That is very critical at this particular juncture. Here's some example problems to convert into rates. Pause the video at this point to give yourself a chance to do the examples. So your answers are as follows. If I divide 9 by 3, I get 3. Therefore, I have 3 tennis balls per can. Again, the units are critical here. If I have 55 students and 11 teachers, that gives me 5 students per teacher. If I have 81 cents for an 18-ounce can of tomato sauce or anything like that, it's really 4.5 cents per per ounce. That is our unit price. Here's a bit more difficult problem. It is a word problem, however, we call it an open-ended response question because of the fact that we do not need to use a variable in this case. We do not need to set up our normal word problem scenarios where we need to do all 5 things. What we'll do here is look at the problem. Price Chopper sells the regular bottle of Windex for 21 ounces for $1.50. The supersized bottle is 34 ounces for $2.19. The supersized bottle is 34 ounces for $2.19. And as I said, the regular sized bottle of Windex is 21 ounces and $1.50. So let's find to the nearest cent the unit price or the cost per ounce of the regular bottle, find it for the supersized bottle, and figure out which one is the better buy. Since it says cost per ounce, I want to put the cost on top and the ounces on bottom. So for the regular size bottle, it's $1.50 divided by 21, which approximately gives me 7 cents per ounce. When the supersized bottle is done, we have $2.19 divided by 34 ounces. That gives me 6 cents per ounce. Now, because it is a lower price, the supersize is a better buy overall. It might not seem like much, but if you're looking at a product like Windex, a product that never goes bad, it's probably best to buy the supersized bottle. Your homework in this section is textbook pages 210 to 211, numbers 4 to 28, multiples of 4. Again, that means count by 4 for those of you that don't know your multiples. I also want you to do problem number 34. Please also complete textbook page 213, numbers 4 to 16 even.